Okay, in this video we are going to see the two different ways of controlling a contactor. As you see, here we have a circuit breaker that is used to break both the phase and the neutral. Here we have a contactor. As you see, here we have a contactor, and here we have a two type of push button, that is stop push button and start push button. So the stop push button is used to stop the contactor. In turn, it helps to stop the motor. No, it helps not to allow the motor to run, but start current. This start push button helps to help the motor run, or to for the current to flow from the source to the motor easily. So we have different ways of controlling this contactor. So the first one is a two-wire control method. That means when phase and neutral is directly supplied to the two coil terminals of a contactor. In this case, we are talking about an AC single phase contactor that supports a 230 volt AC and a 15 hertz frequency. So here we are as a switch, we are using a breaker. It breaks both phase and neutral. Then this output from the breaker will be directly supplied to the coil terminals of this contactor. So as we saw in the previous video, a contactor has too many parts. That's the moving part of the armature, the stationary part, and the coil that energizes the contactor, or the place where an electromagnetic induction or an electromagnetic force will be applied to the armature. In turn, the normally closed contacts will be closed. So in this condition, the current will flow directly to the load. So in this first phase, we are using a single wire. A single wire helps that is directly phase and neutral is applied to the coil terminals. Here, as you see, we have two terminals, A1 and A2. A1 and A2. So these points are directly connected to the coil inside this contactor. So this contactor supports a voltage, an AC voltage of 220 volt and a 50 or 60 hertz frequency. So the first thing is we are going to connect these things directly from the output of this breaker. So these two wires, as you see, the green wire and the black wires are directly supplied to the coil terminals of A1 and A2. So as you see, the contactor will be energized and it will close its open terminals. So an AC power is directly supplied to the coil terminals, as you see. So here we have 2 points, the normally open points. These are all the normally open points. When the coil of this contactor is energized, this normally open contacts will be closed. So the next one is, here we are going to use a selector switch. So the selector switch is a device that is used to select the position of to make the contactor on and off, or in the normal operating condition. So as you see, we are giving the neutral directly to the coil contactor A2, the neutral from the breaker is directly supplied to the coil A1. So the phase is the one that is controlled using a selector switch. So we are going to control the phase in this case. So when you press it, then in this case the contactor is, as you see, the selector switch is in the off position. Here we have contactors. These selector switches are used for many purposes. like to control a given system automatically and manually. Here you have, it has position 0, position 1 and position 2. As you select, the position 1 will be the manual position. That means the coil will be, or the contactor will be energized using simply hand. Okay, we can rotate the contactor using hand. So when you press the off push button, the contactor is de-energize itself in position 2. This when you turn the selector switch to position 2, it automatically operates itself. So there is no stop or start push button in automatic system. The contactor controls itself. The third position is position 0. That means it allows the selector switch allows no flow of current from these points, from 3 to 4 or from 4 to 3. So no flow of current we get in this position. As you see, when position 1, when this selector switch is rotated to position 1, this coil will be energized and this normally open contact will be closed, as you see. So now the contactor is energized. When you bring the selector switch to its original position, then it will be de-energized. So we are cutting the flow of current, and the contactor will turn to its original position or to its off or to normally open condition. So this is a basic principle that selector switches are directly connected. So here we are using the two-wire controlling system. The two-wire controlling system. The two-wire system controlling system is used where there is no switch. That means directly an AC source is applied to the contactor coils. That means we are using the contactor. I mean the breaker to control this contactor. When you put this breaker in the off position, then the contactor will be off. When you bring to its on position, the contactor will be on. So this is not effective way to control a contactor. Okay, or turning this breaker on and off will damage this circuit breaker. So we are going to use a switch. That means there are different types of switches. We are going to use start and stop push button switches. So in this case, it helps to control the whole system without damage. So the other condition we are going to see is the three-wire control systems. So the three-wire control system is the system that is used to control this contactor. That means when you press the start push button, the contactor will be energized because the current will flow from the output terminal of the breaker to the points or to the terminals A1 and A2. In this moment, in this condition, the contactor will be energized. When you when you put the push button, when you take away your hand or your finger away from the push button, the contactor will be off because the flow of current will be open because no current flows from the output terminal of the breaker to the contactor. So to reduce this problem, we use the self-hold system. The self-hold system is a system where a contactor gains a current in another system. That is the contact points 13 and 14. So as you see, here we are going to use two type of contactor switches. That means two types of push button. That is a start push button and stop push button. So the stop push button has terminals, terminal 1 and 2. The stop push button here, as you see, the stop push button has terminal 1 and terminal 2. So this is a normally closed condition. That means when you apply current in position in point 1, then the current will easily flow from point 1 to point 2 because it's normally closed and it allows a flow of current from this point to this point. When you press this push button, it breaks the flow of current, because the normally closed contactor will be normally open when you push this stop push button. On the other hand, these point 3 and 4 are normally open. As you see, this NO indicates the normally open conditions. That means when you supply a current, supply a current or a source from point 3 to point 4, there will be no flow of current in the normal state. That means in the off state, no force is applied to the button or the terminals of this start push button. But at the moment you press this start push button, it closes the normally open points and it allows the flow of current from point 3 to 4. So this is the working principle how stop and start push buttons works. So it has something similar to the selector switch. So here we are going to see the connection. We connect these points. So here we have 3 wires, as you see, wire 1, wire 2, and wire 3. So wire 1 is directly supplied or directly connected to point 3, or the white wire is directly connected to point 3. Here this color wire, also the blue wire, is directly connected to point 2 of the stop push button, as you see. And we shunt these 2 points, point 1 and point 4. Point 1 and point 4 is directly connected or shunted using a small wire, as you see. And we have one more wire. We have one more wire left, as you see. This one more wire is directly connected to point 4. Directly connected to point 4. So here we have this wire is directly, we will give a phase to this terminal. Okay, when you give phase to this terminal, then the current flows from this to this and from here to here. Okay, the moment you press this point, the moment you press the start push button, then there will be the current flow point from point 3, from point to point 4 to point 3. And here we have the yellow wire, I mean the white wire. So this wire, the white wire helps us to connect it with the terminals of a contactor. So as you see, the white wire is directly connected to the contactor coil A1, and here, as you see, this colored wire is directly connected to the point, the terminals 14. That means 4030 is normally open contact. So in this condition, when you turn on the breaker, as you see, when we press the start push button, as you see, it is energized. The normally open contacts are now normally closed. When you prevent the hand, then it will go back to its original position. Okay, because there is no flow of current when you prevent, or when you take your hands away from this point. So we have another science to apply here for the contactor not to turn its original position after we removed our finger. So this process is called self-hold. That means even if the current that directly flows from this push button, okay, will be directly connected to point 13 and 14. That's normally open points. And even if you this normally open start push button is de-energized or not pressed, then there is another way for the current to flow from the circuit breaker to the point A2. So it is a least possible way that works according to this system. So that this is a way how we are going to control this system. So here we have breakers are devices that are used to protect a short circuit, to protect overload, and to be used as a breaker. So breakers have three functions. Okay, this type of breakers has three functions. The first function is to prevent overload. Okay, when the current above the rated current is supplied to the load, then they will break that current. Okay, because as you see here we have a C10. C10 is C is the current and 10 is the amount of current in ampere. That means the maximum current that this breaker allows to flow is 10 ampere. Okay, when the current level is above this level, then this breaker will be de-energized or will bring itself to its off state. So it's in one hand it helps to prevent overload. Another point, it helps to prevent short circuit. Okay, short circuit, when a circuit is short, then the current will rise very high. Okay, there we will get a maximum amount of current. So this amount of current helps the this circuit breaker to break the system, because the current rises to very high level, and this it helps to break this breaker. And the third one is we help this breaker as on a switch. The second one is here we have a contactor, as we see in the previous video. Contactor has main part, that is the armature, the moving end, the stationary part, and the coil, that is the main part of the contactor, where an electromagnetic field is induced. That is, a temporary magnet is developed, and that attracts the movable armature, that in turn closes the normally open points, as you see. So it has input terminals, input points, 1 L1, 3 L2, and 5 L3. These are the input terminals of the contactor, and here we have 2 T1, 4 T2, and 6 T3. So 6 T3. These are the output terminals that goes directly to the load. Okay, sometimes we are going to use an overload relay. Overload relay helps to prevent the motor or any other devices from overload or from damage. So this overload relay is directly connected to the output terminal of this contactor. So now the output terminal of this overload relay will be directly given to the motor terminal or any other load. So it has two terminals. Now the rest one is point 13 and 14 are the normal open contacts used to make this contactor self-hold. That means the other possible way the coil will get a current. Okay, even if you not press, after you press the start push button, then the contactor must be energized even if you lift your hands. So this way is done using these pointers, point 13 and 14. The other here we are going to see is the push button. That means the start push button and the stop push button. The start push button is used to start the energizing system of this contactor, which in turn energizes our load. That means this system allows the flow of current from the flow of current directly to the load. The stop push button is used to stop the flow of current, which in turn stops this contactor and also the load. It helps to stop the load. So I think you got something useful for. So I will revise this in my another video. We will see about breakers. There are different types of breakers. There are different types of push buttons. There are different types of contactors, and this is a highlight. So we will see also how star delta connection works, how such what are the components we are going to use in star delta connection system, what is the current level, what is the breaker rating we are going to use, what is the overload relay type we are going to use, what is the type of push buttons we are going to use, how many push buttons we are going to use in a star delta system. So we will see all this